Okay, real quick one for today. Let's imagine we're launching a projectile at some given speed v naught. That's the v naught in this equation. But we're free to vary the direction of launch over all angles between 0 and pi over 2. So we could launch it straight horizontally, or we could launch it straight vertically, all of those angles. And our question is, well, what's the average landing position? In other words, what's the average range of the projectile, keeping the speed fixed, but allowing the angles to vary continuously from 0 to pi over 2? So that's pretty easy, honestly. If we want to calculate the average of this range over all angles, I'm going to think of this as sort of a mean value theorem of integrals technique. I'll take my integral over all possible angles. So this will be from 0 to pi over 2. Those are the allowed angles here, of my range formula, which does depend on angle. But of course, I'm averaging. I'm not just adding. So I should divide by the interval size. In this case, pi over 2 minus 0. And make sure you do this in radians or it's not going to work. So we just want to do this integral. The 1 over pi over 2 minus 0 becomes 2 over pi. I've got my v naught squared over g that we've done a million times, sine 2 theta. That is the range formula on level ground. This is a constant that can come out to the front, and then we just have to do the antiderivative of sine 2 theta, which is very easy. The antiderivative of sine, well, we'll get a 1/2 because it's actually a sine 2 theta. It'll be a cosine 2 theta, and don't forget that the antiderivative does pick up a negative sign. All right, this bit here, when we plug it in, pi over 2 times 2 is pi. Cosine of pi is -1. So I'm going to start with negative half, which is 1/2. And then I'm going to subtract -1/2 times the cosine of 0, which is, of course, 1. So negative will become a plus, and 1/2 plus 1/2 is 1. So at the end of the day, my average distance is 2 over pi v naught squared over g. Or in other words, 2 over pi times my maximal range, which, remember, is at a 45-degree angle. Numerically, this is approximately 0.637. So it's kind of interesting that the average range is not half. It's not like the halfway point. It's a little bigger than that. You end up averaging somewhere kind of almost 2/3 of the way over from where you started. So that's a nice quick little practicing of taking an average of a continuous function, but we end up with this nice result for the average range of a projectile taken over a continuum of different launch angles. QED.